Okay, now we're into part 2 of chapter 6.2, operation on vectors. Okay, today we're going to do scalar multiplication. So we will start with this diagram from page 178. If I have a vector A, okay, scalar multiplication just means that the magnitude of the vectors increase. So if I want 2A, what happens is 1A, 2A, the length of A is doubled. Similarly, if you look right at this vector over here, 3 over 2a is 1.5a. So I have 1a and I have half an a. So this becomes 3 over 2 of the vector a. Similarly, if a is going this way, negative a will be going downwards this way. So if you look at this vector over here, if this is a, negative 2a means that I reverse the direction and I go down twice. So this is negative a, this is negative 2a. Similarly, if this is negative a, then this will become half of that. This is negative half of the vector a. Notice something about this. Whenever we have a scalar multiplication, okay, all of them will be parallel. Only the magnitude will change, but for them the direction may change to be the opposite direction, but all in all they will still be parallel. Okay, now I'm just going to go through some questions. First, you can look at page 179 of try it 15. Okay, so I'll just quickly go through this. So for try it 15a, I want 3d and 3/4 of d. So in this case, it's a scalar multiplication. I can actually add 3 and 3/4. They are like terms. So in this case, what I get is 15 over 4 of the vector d. So I just take 15 over 4, multiply to the vector d. And what I'll get is negative 30 and negative 15. Now, for part B, we have 7c minus 7d. Okay, same thing, the same rules of algebra actually will apply. Okay, 7c minus 7d. If I factorize 7, I can have c minus d. So in this case, c minus d, I just do a quick calculation. C minus d should give me 13 and 6. All these figures are gotten from here and here. So just multiplying in the 7, and I will get 91 and 42. Okay, now on to try it 16. It's given that B and C are parallel. Okay, so parallel, as we have learned, okay, whenever you multiply by a scalar, the vectors will be parallel. Okay, so now what they want is the vector, they want me to find the value of n. So if I know that the vector B is parallel to the vector C, so one statement that I can make, right, is that the vector B is k times of the vector C. Why k times? You multiply by a scalar, so k is a constant. You multiply it by scalar multiplication, the vectors will be parallel. So this is something that you actually must take note of. So whenever they say that it is, when the vectors are parallel, so for example they say that if vector A is parallel to vector, let's say f, for example, then I know that vector A will be k times of vector f. This relationship is very, very important, so please do remember this. Now I'll just erase this so that you don't get confused. So back to the question, part A. So I know that B is k times of C. So if I set it up, negative 3, negative 1 is k times of 6 and n. Okay, so I can say this. So I will use a highlighter. So negative 3 is related to the k and the 6. So I'll say that 6k is equals to negative 3. My k value will be equals to negative half. Okay, since I know that k value is negative half, now what I can do here is this. I will now work from here and here. So I will say that negative half n equals to negative 1. So my n value is simply equals to 2. Then now finally find the ratio of the two vectors. Okay, so now I know that b is equals to -3, -1. I'm not going to do the calculation here. You should be able to do this by now. The magnitude of vector b is square root of 10 units. So vector c, when n is equals to 2, okay, so n is equals to 2 over here. Therefore, I know that vector c is 6 and 2. And therefore, the magnitude of vector c is square root of 40 units. Hence, what I know that is the magnitude of b is to the magnitude of c is square root 10 is to square root 40. I know some of you may be rather excited, or you may want to go and square both sides so you get 1:4, but that will be wrong. Okay, so it's wrong, okay, to go and square both sides because you actually change the value here. So what you can actually do here is this. If you just actually, the simplest way you can employ, okay, is to use your calculator. Just go key in square root 10 over square root 40. You press the equal sign. You notice that the value that the calculator gives you is 1:2. So you make intelligent use of the calculator. You find that the simplified ratio is 1:2. Okay, we move on to try it 17. It can be found on page 181 there. Alright, so same thing. It tells you that R is equals to M times P plus N times Q. So let me just write that down. Vector R is M times P plus N times Q. So my vector R is 1, -12. Okay, M times P will give me M times 2M plus N times Q. So it will give me 2N minus 3N. So basically I've just translated this into this. Then if I simplify further on the right hand side, I get 1 -12 is equals to M plus 2N and 2M minus 3N. So if you notice here, what I'll have is actually a pair of simultaneous equations. So I can say that M plus 2N is equals to 1. Okay, then there is equation 1. And I also know that 2M minus 3N is equals to -12. That is equation 2. So I'll just very quickly solve this, as this is not the emphasis for the lesson. From 1, M equals to 1 minus 2N. Okay, then what I can do here is this. Okay, this is equation 3. So I will substitute equation 3 into equation 2. So 1 minus 2N minus 3N equals to -12. If I just 2 minus 4N minus 3N equals to -12. -7N is equals to -14. My N value is equals to 2. And my M value equals to 1 minus 2 times 2. My M value is -3. So M equals to -3. N is equals to 2. Okay, now we have try it 18. Alright, so try it 18 is something that is different now. Okay, but don't worry, we'll work through this. I think it's best that if you have a textbook next to you so that you can actually follow on the diagram as I work through this question. So now is for A, part 1. Okay, they want CA. Okay, so this will be a combination of what we did last week, okay, and what we're going to do what we've just learned a few minutes ago. So CA, okay, another way of saying CA is actually the vector CB plus BA. Okay, so now what I'm going to do here is this. Before I even start, right, they tell us this that AB is 3 times of AP. So this is R. So this whole thing will give me 3R. Okay, so or if you want from here to here, this is 2R. So So if I just fill it in, this portion here is 2r. Okay, then I also know that AC is 2 of AM. That one I have no idea. BD is equals to 2 of BC. So if BD is 2 of BC, it means that this BC is Q, BD is also Q. So this whole thing here is 2Q. Alright, so what I've done here is I fill in the information based on what I know from here and here. Okay, because we are going to need it pretty soon. Alright, now let me just erase all of that here. So now if I need to begin, I'll say that the vector CA is equals to the vector CB plus BA. CB is equals to negative Q. Okay, because if you notice from the question, oops, it's a bit too, okay, the nib is a bit too thick there. Okay, this is Q. Okay, if BC is Q, CB is negative Q. Then BA, we know that the whole thing is 3R. Coming downwards is 3R. So if we go the other way, it will give me negative 3R. Hence, CB plus BA is negative Q minus 3R. For part 2, we have CM. Okay, for CM, okay, I know that CM is half of CA. How do I know that it's half of CA? From this portion here, where you tell me that AC is 2 of AM. Means that M is the midpoint of AC. So therefore, CM is half of CA. So I just erase this. And I'll say that CM, since M is a midpoint, is half of the vector CA. So I just apply scalar multiplication. Therefore, my CM value, you have to expand, is negative half Q minus 3 over 2R. Then I move on to part 3, which is DM. Okay, DM is over here, and then what I can do here is this. DM can also be DC plus CM. Okay, so just let me write it down. DM is equals to DC plus CM. So DC is negative Q. Okay, and then my CM value can be found from part 2 here. So my CM value is negative half Q minus 3 over 2R. Okay, what we can do here is this. If you have problems with, let's say, adding fractions, negative 1Q minus half Q, just use your calculator. You'll find that you get negative 3 over 2Q, then minus 3 over 2R. Okay, finally for part 4, we have this MP. The value of MP is equals to MA plus AP. So if you look here, MP, one way is either you can use MC plus CB plus this final vector here plus CP. So this plus this plus this, okay, I'm sorry, this plus this plus this to get MP. Or the shorter way for me to find MP is to actually use MA plus AP, like this. So if MA plus AP, what we get is MA value, I already know the MA value as negative half Q minus 3 over 2R. Okay, you may be wondering where I got this value from. Actually came from here. The CM and MA have the same value. Okay, they're the same, they're equal vectors. Hence, if CM is this, so therefore MA will have the same value. Then plus AP. Okay, so what I will get down here is this. AP is R. Okay, so it's given on diagram there. If I simplify everything, I'll get minus half Q minus half of R. Okay, write down two facts about dm and mp. So what I am dealing with now is dm and mp. I'm dealing with this and this. So I think I don't need part A1 and A2 anymore. What I'll do is I will just select all of them. Okay, I will resize and I'll make it small so that I have a bit more space to write on. Okay, so now if I notice this, okay, dm, how is dm related to mp? So if you notice down here, if I take 3, I multiply here, I get negative 3 over 2q. I take 3 and multiply, I get negative 3 over 2r. So in short, right, actually, what I can say about mp and dm is this. dm is actually 3 times of mp. Alright, you have to do by observation. If you observe from here, it's negative half q minus half r. Here is times 3, is minus 3 over 2q minus 3 over 2r. So my first statement is dm is equal to 3 times of mp. So I can make statements about this. Okay, so one of the there are quite a few statements I can make, alright, but I will say this. Okay, the first statement that I can make is that dm and mp are parallel vectors. How do I know they are parallel vectors? Because dm is k times of mp. The second thing is this. Okay, since they have a common point m, alright, the common point m is here, so I can make the statement that since they have a common point m, okay, d, m, and p all lie on the same straight line. Alright, okay, so those are my two facts. Okay, I will move on to the next one. Okay, I'm now on exercise 6.2. This is on page 184 of your textbook. Okay, just take a moment. Okay, go and flip and go and read. Okay, the question, which is 10a. Okay, so 10a says this: find the values of a and b. Okay, so if I start from this thing here, so I have 5 times of vector p plus 1 time of vector q is equals to negative 2 and 7. So I have 5a plus 3, 5b minus 8 is equals to negative 2 and 7. So this is actually quite a simple question to solve. 5a plus 3 equals to negative 2. If I solve, my a value is negative 1. And also I know that 5b minus 8 is equal to 7. If I solve for b, my b value is equals to 3. Okay, I will now do question 11 on page 184. Okay, P and Q are parallel. So you see, once you see the word in vectors parallel, I know that vector P is k times of vector Q. So if I set that up, what I get is 8 and negative 10 is equals to k times of n and 15. So I start first from here. Negative 10 is k times of 15 times k. So I'll say that 15k equals to negative 10, k equals to negative 2/3. Once I've obtained the value of k, what I can say is this. Now I'm focusing on this 8 and k times n. So I'll say negative 2/3 of n is equals to 8. If I solve, my n value very quickly is equals to negative 12. Okay, I'm now on question 13, alright, on page 185. So, it's given that ABC is a parallelogram expressed as the following as a single vector. So AB plus BD plus DC is simple. So I go AB plus BD plus DC. I started here, I ended here. So my resultant vector is actually this one here. It's from A to C. So very simply for part A, what I get is simply equals to AC. For part B, DC plus BC plus CA. So it's DC plus, so if I were DC, alright, plus BC, okay, BC, okay, plus CA. So if I don't use DC, I can actually rewrite it as AB plus BC plus CA. So I start here, I walk, then I go back to the original point. If my starting point and my ending point are exactly the same, it is a zero vector. So in this case, I get 0. So for part C, what I get is AB minus half of DB. So what I can rewrite it as is AB minus EB. So if I get AB minus BE, okay, see, so what I'll do here is this. If I say that AB minus half of DB is equals to AB, half of DB is equals to EB. Okay, so it's minus half of EB. So negative EB, I can actually write it the other way as negative of a negative EB will give me positive BE. I change the direction of the vector. So AB plus BE in essence will give me the vector AE. Okay, I'm on page 185. We will now do question 14. Okay, express the following in terms of vectors U and vectors V. So if I begin here, dA, okay, dA is simply down here. So it's DO plus OA, or it can also be DO is the same as OA. They have the same direction, same length. So therefore, DO is also the vector U. So therefore, I say that dA is equals to 2 of vector U. For part B, I need AB. So back to the diagram. AB, alright, can be AO plus OB. So let me write down. AB is equals to AO plus OB. So what I get is AO is negative U, then OB is positive V. So it's negative U plus V. Part C, I'm looking for EA. EA can be rewritten as EO plus OA. So this EA, it can be EO. Okay, EA is this. So it can be EO plus OA, like this. So EO plus OA. The vector EO is actually equals to the vector OB. So this is V plus U. Finally, for part D, we need to find AC. Okay, for AC, what I can do is this. It's actually AO plus OC. Okay, OC will actually be related to AB. They are the same vector. Okay, because OC is going this way. AB is a parallel vector, same magnitude, same direction. So OC and AB are the same lengths. So what I first get is AO is negative U, then plus OC. So OC in this case, alright, is the same as vector AB. So it's plus negative U plus V. So if I simplify, I get V minus 2U. Okay, we are at the final question for this topic today. So now what I'm going to do is this. Let's just start this off. A1, Then let me just erase this word n here. AP over here is the same as saying AB minus PB. Okay, so in this case, what I will get here is this. Okay, AP is equals to AB minus or AB plus BP or minus BP. So my AB value is 3V minus away V is equals to 2 of V. AC. The vector AC is actually quite simple. The vector AC is AB plus BC. So I get AB plus BC. What's the value of AB? Okay, the value of AB, as we know from above, is 3V, and the value of BC is U. So it's 3V plus U. Okay, now we move on to part 3, QP. QP in this case, okay, is going downwards there. If we just take a look, this is QP. Okay, so QP can be equals to QD plus DA plus AP. Okay, so that is equivalent to QP. So if I start writing there, QP is equals to QD plus DA plus AP. So in this case, it is negative V, then DA is negative U, and AP itself is plus 2V. If you simplify everything, it is V minus U. Part 4, AR. So AR, okay, there's a few ways to do this, but I can actually do it as AR. Okay, so where is AR on the diagram? This is AR. Okay, AR can be AD plus DQ plus QR. So if I start writing, AR is AD, which is the vector U, plus DQ. Alright, I think I better write the whole thing out. So AR is equals to AD plus DQ plus QR. So in this case, AD is the vector U, DQ is the vector V. QR, okay, is equals to QP. And do we have QP? Yes, we do. QR and QP are the same vector, all right? So in this case, okay, we have the QP value here, is half of QP rather. Okay, R is the midpoint. So I also know that QR is half of QP. So in this case, QR plus half of QP, which is V minus U. So if you simplify, is U plus V plus half V minus half U. Simplifying everything, what I get is half U plus 3 over 2 of V. Okay, now write down two facts for vectors AC and AR. So just I need a bit more space here. So let me just resize this. Okay, now what I need is AR, okay, and AC. So I know that my vector AR is equals to half U plus 3 over 2V, and my value of AC, okay, AC, what we had was 3V plus U. So you notice that, right, for these two vectors, they are actually similar, except they differ by a factor of half. So if I take half times 1U, I get half U. Take half, multiply to 3V, I get 3 over 2 of V. So I can actually make a statement here to say that by observation, AR is equals to half of AC. Okay, so now I can make the statement there to say this: since the two vectors are in the same direction and have a common point A, A, R, and C are all lie on a straight line, and that AR is equals to half of AC. Okay, and that concludes my lesson on the second part of the operation of vectors.